Hey, this demonstration video will show you how to build and simulate a simple well using Pipesim 2014.1. I have just now created a new well-centric workspace. With a well-centric workspace, I see my well schematic here on the left-hand side, and I can enter all the data using various tabs on the right-hand side of the property editor. So to build a well, I can drag and drop any of these objects from the ribbon on the wellbore schematic like this. So I have just added casing and tubing. I can have a simple mode or detailed mode where I can add multiple casings, liners, or open holes. For this, I'm going to stick to simple mode that allows me to add one casing and one tubing. I can edit the tubing informations right here, or I can select a specific casing. For example, in this case, I want a 7-inch casing from the database. I can select like this. For the tubing, let me select a size in excess of 2.5. I can use a special filter for that. Let me define my tubing depth a bit. So now I have the right casing and tubing in the well. My next step is to define deviation survey. Now I don't need to do anything if I have a vertical well. However, if I have survey data, I can use appropriate type and put the survey data right here. For this, I'm going to stick to vertical. I'll also skip the downhole and artificial lift tab for now. Let me go to heat transfer. Here I can define soil temperature at wellhead. This effectively allows me to model geothermal gradient from reservoir up to the surface for heat transfer calculations. And next, we are going to add completions. I can do this in two ways, like either drag and drop here, or I can use the plus sign right here. So first I need to specify a completion depth. You will notice that whenever you define a completion, a flow path is shown on the schematic, as you can see the green arrows here. This is the path the fluid is going to take being produced from the reservoir to the surface. As you can see, it is producing up in the annulus as well as in the tubing. I can control the flow path by simply inserting a packer, which effectively blocks the flow going through the annulus. Likewise, the objects such as sliding sleeve can be used to control flow path between annulus and tubing. If I just open it, you can see now the flow is going through annulus as well as tubing from this point up. I can also add a tubing plug to block the flow going up the tubing. Let's select the completion. There are different inflow performance in Pipesim, from simple well PI to more sophisticated Darcy, which allows you to enter detailed reservoir properties, as well as you can specify skin based on the completion methods that you have selected. For this simple model, I am going to specify well PI. Note that for any completion, source, or injection, I need to specify a fluid model. For this, I can define a fluid model right here. As I select this new button, it opens up the fluid selection. I can use a template of light oil and gas. This is a black oil fluid. Let me define my gas oil ratio and correct my water cut. I can go more detailed in defining contaminants or even calibrating data. But for this case, I'm going to stick to the simple fluid model. And when I have done that, I'm now going to define the reservoir properties. As soon as I have entered the relevant information, I can see IPR plot generated and displayed here. Let's correct for two-phase behavior below the bubble point. Now if I have this data, I can use that to tune my productivity index. This is fine for now. Finally, I am going to add surface equipment. To select surface equipment, I can simply click and drop this area here. So I have added a choke and a sink. Let me now connect it using connector from well to choke, and I'm going to use a flow line to connect choke and sink. I can then select each of the objects to define required data for these. And with that, I'm going to run simulation now. I do not have a validation message to take care of. So to run simulation, I can go to the Home tab and I can run any of these simulations here. For this case, I'm going to run nodal analysis. As I select nodal analysis, I'm prompted to specify a nodal analysis point. I have a couple of options here, bottom hole and wellhead. As I select bottom hole, it will insert a nodal analysis point. As you can see. Now, we can move this nodal analysis point anywhere in the system in order to break the system into two. So now I'm going to put an outlet pressure of 200 psi and I'm ready to run the model. So this is my resulting nodal analysis plot, and there's a table on the left hand side that shows me pressure and flow rate conditions at nodal point. Additionally, on the profile result, I can see the profile corresponding to the operating point. I can also view the result in a tabular view. As you can see here, how the different parameters are changing along the profile. This concludes my brief demo on modeling and simulating simple well using Pipesim 2014.